jurusan hama dan penyakit tumbuhan yang secara berkala bisa mengadakan acara visiting lecture ini. Ini suatu acara kebanggaan bagi kita di Fakultas Pertanian. Dan ini suatu merupakan respon terbaik kita bisa seperti ini. Posisi sehingga kita bisa mendapatkan advantage dari kondisi pandemi. Oleh karena itu, Fakultas mengucapkan selamat dan sukses kepada jurusan.
Halo Pak Dekan. Jaringan Pak Dekan kurang stabil, Ciko. Pak Dekan. We are waiting for a while. And for your information, for all participants, Dr. Rafiq called me just now. He will be coming in visiting lecture, insyaAllah.
Oke.
Pak Dekan, mohon maaf, interrupt you.
Mohon maaf juga ini saya keluar sebentar juga bisa masuk lagi, alhamdulillah. Saya kira itu.
Jadi insya Allah Pak Dekan, Pak Rafi
iya,
akan datang.
Ya, alhamdulillah kita mengucapkan puji syukur kehadiran Pak Rafi bersama nanti Bapak Dr. Hermanu untuk mengkaji tentang rekayasa ekologi di budidaya padi ini. Dan saya mohon maaf juga barusan saya keluar karena sinyal yang terganggu. Baiklah kita lanjutkan. Saya kira itu sedikit sambutan dari kami selaku pimpinan Fakultas Pertanian. Baiklah Bapak Ibu sekalian, kita buka acara visiting lecture ini dengan bersama-sama membacakan basmalah. Bismillahirrahmanirrahim. Demikian saja, wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay. Thank you very much, Mr. Dr. Munzir Busnia, for a very useful speech for all of us. As we have finished our opening to lead the next session, I would like to introduce Mrs. Dr. Mai Sarawati as moderate the seminar today. She is one of lecturer in Plant Pest and Disease Department of Agriculture Faculty, Universitas Andalas. She has received bachelor degree and master degree at Universitas Andalas. She taken her doctorate degree at Universitas Gadjah Mada. Now, allow me to welcome the moderate. Please join me in welcoming at a round of applause.
Thank you very much, Dina Satria, our graduate. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning for all of you, Bapak dan Ibu, our students, and the all participants that visiting lecture, organized by Plant Pest and Disease Department, Faculty of Agriculture, Universitas Andalas, Padang, Indonesia. First of all, I would like to say greeting for the Honorable Dean, Faculty of Agriculture, Universitas Andalas, and the Honorable Head of Plant, Pest, and Disease Department, Faculty of Agriculture, Universitas Andalas, and for our speakers already being here now, Bapak Dr. Hermanu Triwidodo, from IPB University. Thank you very much for joining here. And my name is Shahrawati. I'm a lecturer at Plant Protection Department, Faculty of Agriculture, Universitas Andalas. And I got a responsibility to be a moderator in lecture sessions in general topic, ecological engineering on rice cultivation. Ladies and gentlemen, why we choose to talk about rice? Yesterday we talk rice, today we talk rice, and maybe tomorrow, I'm very sure, we still talk about rice. Because rice is staple food for majority human being around the world, including Indonesia. Then why we choose ecological engineering? Ecological engineering is one strategy to increase biodiversity and strengthen ecosystem services in rice fields. And as far as we know, maybe Dr. Hermanu better know about me, from me, ecological engineering is included in IPM, Integrated Pest Management. So it is very important for discussion. And for your information, in Padang, West Sumatra, we are facing now rice damage due to brown plant hopper outbreak. And our farmer still strong belief that insecticide is problem solver to decrease the impact. Okay, ladies and gentlemen, in lecture session, we have two speakers. We'll talk more about ecological engineering in rice cultivation. Dr. Hermanu Triwidodo from Plant Protection Department, IPB University in Indonesia, and also Dr. Ravindra Joshi. He said he will coming in visiting lecture today. He come from Philippine Rice Research Institute. We have two amazing speakers now. For information, each speaker has 30 to 45 minutes for presentation. And after both presented completely, it will be followed by discussion. We will discussion until 11 or 11:15. For first presentation, I cordially invite Dr. Hermanu Triwidodo. Excuse me, I need a while. Okay, I share screen for introducing Dr. Hermanu Triwidodo. I think I get trouble for my signal. Okay, it's working. Okay, we will go to Dr. Hermanu Triwidodo. Dr. Hermanu will talk about ecological engineering on rice cultivation in Indonesia. Firstly, I will introduce Dr. Hermanu Triwidodo for you all. He is a lecturer at IPB University, especially at Plant Protection Department. And I want to say he is in this month, 2 days more will birthday year. So I want to say happy birthday for you, Dr. Hermanu Triwidodo. All the best and happy here and hereafter. He born on January 22nd. He lives in Bogor, Indonesia. Bachelor degree obtained from IPB University in the fields of entomology, and then he get 2 master degree in the field of entomology and then biometric in Wisconsin University, USA, and PhD focused on entomology also in Wisconsin University, USA. And Dr. Hermanu has many experiences here and current activities. He is a head of graduate program of integrated pest management at IPB University and general chairman of Gerakan Petani Nusantara, or maybe Indonesian Peasant Movement. Okay, let's continue to the next slide. So, Dr. Hermanu Triwidodo, please share your screen and time is yours.
Terima kasih, Bu Mai. Assalamualaikum warahmatullahi wabarakatuh. Bapak Dekan, Ibu Kepala Departemen yang saya hormati, ini terima kasih, ini suatu kehormatan bagi saya untuk bisa bergabung dengan para kolega di Fakultas Pertanian Universitas Andalas dan juga khususnya dari kolega-kolega saya di Departemen Hama dan Penyakit Tanaman Fakultas Pertanian Universitas Andalas. Senang ini bisa di masa-masa pandemi ini kita masih bisa silaturahim. Semoga kita semua tetap sehat, penuh semangat dan selalu memilih bahagia. Saya tadinya mau ngomong dalam bahasa Inggris dan saya akan minta maaf pada Pak Ravindra Chandra Joshi bahwa saya akan mempresentasikan dalam mixed language, bahasa dan bahasa Inggris, campuran begitu, 99% bahasa Indonesia, 1% bahasa Inggris. Ini juga saya sebenarnya agak ngeri, tapi sebenarnya ingin berbagi saja tentang perkembangan apa yang terjadi, khususnya di IPB, UGM, dan beberapa kawan di Brawijaya tentang yang terkait dengan rekayasa ekologi. Jadi, dan ini juga sekaligus memberikan gambaran bagi adik-adik mahasiswa untuk berani melangkah ke depan, menemukan hal-hal yang baru. Saya izin untuk mohon untuk share screen. Sudah bisa kelihatan, tapi saya masih agak.
Sudah kelihatan, Pak.
Ya, Pak.
Sudah kelihatan, oke. Sebentar, saya mohon maaf ini karena tua jadi agak gaptek juga. Saya, untuk Oke. Jadi saya diminta untuk bicara. Sebetulnya saya mempersiapkan diri setelah Dr. Yosi dari Philippine Rice Institute untuk bicara ini, sehingga saya sebetulnya agak loncat. Tapi pertanyaan saya ini, kalau kita bicara tentang rekayasa ekologi pada pertanaman padi, itu yang mana? Apakah ada? Apakah mungkin? Gitu. Jadi saya lebih banyak nanti berbagi ke arah sana. Saya kaget juga mendengar bahwa tadi ada terjadi ledakan wereng batang coklat di Sumatera Barat. Kebetulan saya sebagai ketua gerakan petani Nusantara dan dari Tani Center pada Oktober yang lalu juga sudah memperingatkan bahwa tahun ini akan ada beberapa ledakan. Ini saya ada kaitannya dengan itu, pas saja yang saya tampilkan. Ini gambar ini diambil di Madiun. Itu ada Babinsa di situ, ada ibu kepala sekolah, ada anak-anak sekolah sedang turun ke lapang untuk seperti melakukan muatan lokal begitu untuk SD, dan mereka sedang mengumpulkan kelompok telur penggerek, dan kelompok telur itu dihargai Rp500 satu kelompok telur. Jadi mulok ada kerjasama dengan dinas pendidikan, muloknya, dan ada reward bagi anak-anak yang mengumpulkan sambil bergembira belajar. Telur yang dikumpulkan itu mereka diminta buat botol plastik begitu yang dipotong lalu dibalik, telurnya dimasukkan ke situ, lalu diamati di rumah apa yang keluar. Kalau yang keluar ulat, ulatnya dimatikan. Kalau yang keluar yang terbang-terbang di sini dibawa ke lapang di beratnya. Jadi ini proses yang terjadi. Pertanyaannya, apakah ini bisa disebut rekayasa ekologi pada pertanaman tadi? Itu satu. Ini dilakukan pada tahun di Madiun itu untuk mencegah terjadinya serangan wereng, karena biasanya di awal tanam yang menjadi masalah adalah penggerek batang. Lalu petaninya panik menyemprot pestisida dan menghasilkan wereng sebagai hama yang muncul dan lebih parah. Ini yang kedua, ini di Klaten. Ketika terjadi ledakan wereng, itu kita membuat satu flyer yang judulnya itu ya, kalau sawah sakit, hama wereng bangkit. Kalau sawah sehat, hama wereng tidak mendekat. Dan itu yang disebut sawah sakit itu adalah sawah dengan miskin bahan organik, makanan predator tidak ada, penyemprotan pestisida, banyak predator yang mati, dan tidak ada predator yang menunggui untuk memakan wereng. Sebaliknya sawah yang sehat itu adalah sawah yang kaya bahan organik, tidak disemprot pestisida, banyak predator, dan predator banyak makan wereng. Karena anjurannya mencegah serangan wereng dapat dilakukan dengan mengembalikan jerami ke sawah untuk meningkatkan bahan organik, menghindari penggunaan pestisida, jangan menanam varietas yang berasal dari mancanegara, dan jangan biarkan sawah tergenang terus-menerus. Itu yang kita lakukan. Pertanyaannya lagi, apakah ini bisa kita sebut rekayasa ekologi? Nah, ini yang seringkali akrab dikaitkan dengan rekayasa ekologi, yaitu penanaman tanaman refugia. Ini ada gambar di Desa Besur, Lamongan. Seluruh desanya hampir diwarnai dengan bunga-bunga. Ini kebetulan di pusat kegiatannya itu ada manajemen tanaman sehat dan sudah dipakai untuk semacam agrowisata desa begitu, diatur rapi. Jadi sepanjang saluran air dan lain penuh bunga-bunga. Ini adalah tanaman refugia yang sedang in sekarang. Lalu kita tanyakan apakah ini juga bisa kita sebut sebagai rekayasa ekologi. Jadi ini berbagi saja ini. Jadi banyak sekali hal-hal yang sudah dilakukan dan saya tahu di Sumatera Barat sejak zaman sahabat saya Pak Joni itu sudah ada Institut Pertanian Organik Indonesia yang ada di sini, lalu SLPHT-nya juga luar biasa. Dan salah satu provinsi ketika beliau jadi kepala dinas itu yang menolak untuk menanam padi hibrida. Nah, rasanya makanya gembira sekali ada diundang ke Universitas Andalas karena mesti ini ada gudangnya kaitannya dengan pengendalian hama terpadu dan kemungkinan mengarah ke rekayasa ekologi. Saya ini sedang berbagi saja, kita mau mengajak berkaca dari evolusi proteksi tanaman dan kemudian membahas fakta dan tantangannya. Ini terutama saya dedikasikan untuk adik-adik mahasiswa, sekedar berbagi saja supaya tahu evolusi proteksi tanaman dan arah kedepannya itu bagaimana. Tentu saja praktek-praktek berkaitan dengan pengelolaan hama yang praktis ini, yang disebut praktis itu adalah dikembangkan berdasarkan pemahaman dan sikap dari pengetahuan yang ada. Dan praktek ini sangat dipengaruhi oleh perkembangan pengetahuan dan pengetahuan sangat dipengaruhi. Jadi nanti kalau pengetahuannya berkembang, pemahamannya juga bertambah, prakteknya juga akan berubah. Tapi juga seringkali ada terjadi bahwa prakteknya ini, si petani ini menjadi yang menuntun di depan, yang mendorong adanya pemahaman sehingga mendorong perubahan pengetahuan juga bisa demikian. Jadi yang ingin saya bagi nanti adalah bagaimana perubahan pengetahuan ini bisa merubah cara kita mengelola hama dan penyakit. Dan mengapa menjadi Departemen Proteksi Tanaman atau Departemen Hama dan Pesakit Tumbuhan adalah departemen yang sangat penting dan terdepan kaitannya dengan pengelolaan agroekosistem. Kita mulai saja dari awal ketika zaman revolusi hijau, pendekatan yang dilakukan itu adalah bagaimana memacu produktivitas suatu tanaman unggul yang kita sudah tentukan dan didorong secara maksimal agar mencapai potensi genetiknya. Pengetahuan sangat pada saat itu ada pikiran begini, kalau suatu tumbuhan itu tumbuh tidak diganggu, mestinya dia bisa mencapai potensi genetiknya secara optimal. Jadi kalau ada hama, penyakit, ada gulma, itu kalau bisa jangan sampai ada, karena ini ada pengganggu. Karena kalau dia mengganggu, potensi genetiknya tidak ada. Jadi itu dihilangkan saja. Dan proteksi tanaman pada saat itu, adalah dengan cara menggunakan racun kimia. Penyemprotan berjadwal, kita dulu tahu 2 minggu sekali. Racun yang baik adalah racun yang dapat bertahan lama di lahan. Kalau bisa, karena konsentrasinya itu adalah memacu potensi genetik tanaman yang kita muliakan, kita seringkali merubah lingkungan agar sesuai dengan keperluan tubuh tanaman. Jadi kita pernah ingat bahwa ada daerah pasang surut yang dirubah menjadi sawah, ada penanaman kedelai di lahan-lahan marginal yang kita pakai, ada program pengapuran untuk naikkan pH, dan ada. Jadi ini merubah lingkungan supaya cocok. Itu yang kita lakukan begitu. Pada saat itu textbook, petunjuk-petunjuk, flyer mengatakan nanam semuanya dengan misalnya untuk tanaman padi yang saya ingat itu perlu urea 200 kg, KCl 100 kg, TSP 100 kg, kapan diberikan, semuanya dalam bentuk paket, dan penyemprotan dilakukan sekian hari sekali pakai apa. Ternyata pendekatan untuk menaikkan potensi genetik itu kalau di kan begini. Jadi karena proteksi tanam bertutup pada racun disemprot secara berjadwal, tapi menghasilkan dampak. Misalnya pencemaran lingkungan, jasad non sasaran mati, hancurnya biodiversitas, gangguan kesehatan yang menumbuhkan persoalan baru dan tidak menjamin tercapainya potensi genetik yang diharapkan. Bahkan produktivitasnya menjadi leveling off, tidak bisa naik lagi atau bahkan turun. Itu kalau di hama dan penyakit itu terjadinya resistensi, munculnya hama baru. Wereng itu ada termasuk hama revolusi hijau, itu karena pemakaian pestisida yang berlebihan. Jadi kalau ingin tidak terserang wereng, harusnya kita sendiri meyakini bahwa selama kita tidak menyemprot pakai pestisida, wereng tidak akan muncul. Ini yang terjadi. Jadi kemudian timbul pelajaran ekologis yang pertama. Jadi knowledge, pengetahuannya berkembang. Gitu. Pengetahuannya berkembang. Kalau tadi itu hanya satu trophic level, tanaman harus dilindungi dari gulma, dilindungi dari hama penyakit, gitu. Satu trophic level. Sekarang pelajaran ekologis bahwa ternyata kita tidak bisa mengandalkan itu. Jadi ada tanaman, ada hama, ada musuh alami. Jadi artinya 2 trophic level atau 3 trophic level misalnya. Itu ada terjadi cara pandang. Lalu juga ada perbedaan pandang terhadap racun kimia buatan. Yang ini akan bermuara pada berbagai aliran. Lalu lahirnya PHT versi awal yang pandangan modern. Jadi kalau di sini kesadarannya bahwa kalau kita tidak hanya satu tropik itu, ternyata ada loh organisme yang mengelola secara alami populasi, mengontrol secara alami populasi dan penyakit. Nah, pada saat itu terjadi pecah, jadi ada 3 jalan, ada yang yang meyakini bahwa pestisida itu sangat tidak baik, jadi perlu ditinggalkan, mengarah ke pertanian organik. Tapi juga ada yang mengarah bahwa penggunaan pestisida secara bijaksana, dalam arti ini tepat dosis, tepat waktu, pemilihan yang lain. Ada juga yang mengarah ke high external technology input, arahnya ke bioteknologi atau genetic engineering. Jadi kalau teman-teman di organik nggak pernah percaya bahwa penggunaan pestisida itu bijaksana, tapi kita yang pandangan moderat ke sana, ini mendorong lahirnya PHT versi awal, kalau dalam bahasa Inggrisnya Integrated Pest Control, yang didorong karena racun kimia berpotensi menimbulkan banyak permasalahan baru, makanya penggunaannya sedapat mungkin harus dihindari. Lalu yang kedua, kesadarannya untuk PHT versi awal, memberikan penekanan dan memfasilitasi agar faktor kematian OVT oleh penyebab alami itu menjadi maksimal. Jadi memaksimalkan peran parasitoid, predator, agen akatoris. Mengoptimalkan cara pengendalian OPT non kimia, seperti pengaturan pola tanam, bercocok tanam, pengendalian cara mekanik, dan lain-lain. Kalau pada masa-masa revolusi hijau, Departemen Proteksi Tanaman, Ilmu Hama dan Penyakit itu dipandang sebelah mata saja. Karena nggak perlu ilmu itu, tinggal nyemprot-nyemprot saja. Tapi dengan ini kita mulai ada. Racun, kalaupun terpaksa digunakan, pilih racun yang spesifik, mudah hilang dari alam, penggunaan harus selektif dan tepat, dan hanya digunakan jika populasi OPT di atas ambang ekonomi. Nah, pada saat itu kalau di Indonesia itu tahun 70-an, kalau revolusi hijau di Indonesia untuk tanaman padi itu tahun 60-an pertengahan dengan bimas awal. Kalau PHT itu mulai muncul versi awal pada tahun 70-an, dan itu perlu pengamatan. Pada saat revolusi hijau dilakukan, recruiting PPL itu besar-besaran karena mereka. Nah, pada saat tahun 70-an mulai direkrut pengamat hama. Karena apa? Karena tadi ada ambang ekonomi, perlu pengamatan. Kalau populasinya di atas ambang ekonomi baru digunakan racun. Jadi di sini tahun 70-an itu recruiting PPL banyak. Ini nanti penting bagi adik-adik karena nanti pada zaman yang sudah berubah nanti kita harus bisa menyesuaikan diri dengan kondisi baru, dengan informasi baru. Kalau dulu memang pengamat dan kita masih dalam posisi itu sekarang. Yang terjadi adalah kita seperti kata konsep ambang ekonomi itu terlalu teoritis dan susah dan sulit dilakukan di lapangan. Dan ini terlalu OPT minded. Jadi kalau petani suruh lihat ambang ekonomi baru nyemprot. Dan penggunaan racun kimia juga masih menjadi upaya pengendalian secara sebagian besar oleh petani. Jadi teorinya bagus, untuk dipahami bagus, tapi untuk dipraktekkan itu susah. Jadi saya tidak pernah melihat petani secara serius memakai ambang ekonomi dalam pengambilan keputusan penggunaan racun. Jadi tetap saja dengan teori yang bagus itu, dengan pengamatan dan lain-lain, penggunaan racun itu tidak bisa dihambat. Jadi tetap saja produktivitas tetap leveling pencemaran terjadi, resistensi munculnya hama baru, plus munculnya generasi-generasi baru pestisida yang didukung oleh pemasaran yang sangat agresif. Jadi itu yang mendorong penggunaan racun yang masih banyak. Oleh karenanya timbul pelajaran ekologis yang kedua, bahwa kesadaran pengelolaan OPT harus didasarkan pada pengetahuan ekologi yang utuh, tidak hanya cukup 2 trophic level saja, tetapi juga dalam pandangan ke generasi ekologi yang lebih luas dengan jejaring makanan dan lain-lain. Lalu kesadaran kelaman pikir cara reduksionis, jadi sangat menyederhanakan masalah yang kadang-kadang buntu, jadi terlalu mata kuda, agronomi mata kuda, tanah mata kuda, proteksi tanaman mata kuda, dan masing-masing jalan sendiri, dan itu membuat kadang-kadang menimbulkan petani, membingungkan petani. Di lain pihak juga terjadi bahwa kesadaran bahwa pengembangan pengetahuan itu tidak hanya berkembang di perguruan tinggi dan di bank, tapi juga pihak swasta dan petani itu juga aktif mengembangkan dan kadang-kadang jauh lebih maju dibanding apa yang dilakukan oleh perguruan tinggi. Tadi ada gambar tanaman refugia itu lebih banyak berkembang di luar sistem perguruan tinggi dibanding atas kesadaran dari temuan dari perguruan tinggi. Oleh karenanya kesadaran untuk saling mengisi dan bekerja sama antar disiplin ilmu itu menjadi penting. Dalam pandangan itu, jadi tadi 1 trophic level revolusi hijau menghasilkan penyemprotan bersistem kalender, sadar, menjadi integrated pest control dan ambang ekonomi yang tidak bisa dipraktekkan secara baik, lalu meningkat ke kesadaran kedua yang melahirkan integrated pest management, pengelolaan hama terpadu, bukan pengendalian, pengelolaan hama terpadu yang memandang ini sebagai sesuatu yang utuh. Jadi untuk lingkungan yang sehat itu misalnya ini digambarkan bahwa tanaman padi adalah bukan tanaman air, tapi tanaman yang perlu air. Oleh karenanya pengairan harus intermittent. Dengan demikian ada komunikasi antara udara dengan ekosistem di bawah tanah, misalnya contohnya O2. Dan juga O2 ini akan bekerja sama dengan diffuser dan keberadaan bahan organik yang bisa memperbaiki struktur tanah dan kesediaan unsur mikro plus bahan organik sebagai makanan mikroba. Mikroba ini akan menjadi makanan plankton, plankton menjadi makanan Sirumecidae, bahan organik juga Collembola, dan ini menjadi makanan predator generalis yang menjaga ini tetap ada. Kalau sekarang terjadi ledakan di Sumatera Barat, ini adalah proses yang terjadi ledakan di Jawa biasanya. Mengikuti banjir misalnya karena tanah tergenang terus, tidak ada komunikasi. Tanah di Jawa miskin bahan organik dari penelitian kita yang kita harapkan 5% itu semuanya di bawah 1%, jadi O2-nya tidak bisa masuk, miskin bahan organik. Mikrobanya jadi kecil, tanamannya tidak tersedia unsur mikro dan struktur tanahnya nggak bagus, planktonnya tidak diproduksi, sirum medisenya tidak dapat makan, polen-polennya tidak ada, musuh alami tidak dapat makan. Jadi sehingga dia tidak ada di lapang. Jadi nanti kalau terjadi ledakan kita bisa lihat apakah ada laba-laba atau tidak. Nah ketika ada wareng datang, ini berkembang dengan cepat. Itu yang terjadi di Jawa. Oleh karena tadi di slide yang kedua tadi ketika di Klaten, anjurannya itu adalah bagaimana menambah bahan organik, tanamannya di pengairannya intermittent, lalu jangan gunakan pestisida yang mematikan musuh alam. Jadi beda tadi kalau harus pakai ambang ekonomi dan lain-lain itu sudah nggak pakai ambang. Di IPB Profesor Aunu mengembangkan cara pendekatan ini untuk PHT, pengelolaan hama terpadunya. Ada 2 tindakan pengendalian yang dilakukan itu. Ini nanti akan relevan dengan pendekatan rekayasa ekologis. Ini adalah tindakan pengendalian preemptif yang dikembangkan berdasarkan proses pemahaman dari pengalaman musim lalu, literatur, pengetahuan pribumi, dan lain-lain. Dan ini disusun dan diintegrasikan pada sistem budidaya tanaman. Nah, di sini sudah orang-orang proteksi tanaman sudah menjamah ke ranah teman-teman agronomi, menganjurkan pemupuan yang tepat, pemilihan varietas, waktu tanam, dan lain-lain itu ada bagian penting dari pengendalian hama terpadu yang termasuk juga pengelolaan tanah, penggunaan mulsa dan lain-lain, terintegrasi dengan teman-teman ilmu tanah. Ini dalam PHT yang dikembangkan pengelolaan hama terpadu yang banyak dikembangkan di IPB, menurut Pak Profesor Aunu, ini adalah 70% dari upaya. Yang kedua adalah tindakan responsif. Tindakan responsif itu dilakukan berdasarkan pengamatan pada musim yang sedang berlangsung pada tanam padi. Kalau populasinya itu membahayakan ambang tindakan dan tidak harus ambang ekonomi yang jumlahnya populasi, tapi juga bisa perasaan, baru dilakukan tindakan responsif. Tindakan responsif juga tidak harus pakai racun, karena banyak juga yang tidak tersedia racunnya atau tidak bisa dibunuh oleh racun varis. Makanya tindakan responsif ditekankan tidak harus pakai racun. Kalau ambang ekonomi kan memang arahnya penggunaan racun. Gitu. Dan kalau tidak ada ya ke agroekonomi. Dan nanti mengarah ke pasar. Ini yang PHT. Gitu. Oleh karenanya dalam SLPHT dan lain-lain yang ditekankan untuk menghindarkan terjadinya serangan hama dan penyakit itu adalah bagaimana melakukan budidaya tanaman sehat, memaksimalkan peran mitra tani, musuh alami, pengamatan berkala, tetap waspada, dan petani yang ahli di lahannya. Jadi subjeknya di situ petani. Ini yang banyak di SLPHT. Kita bisa bicara tentang pendekatan SLPHT secara terpisah kalau tertarik. Tetapi itu tidak memuaskan dari banyak pihak, baik di Gajah Mada, UIBB maupun Brawijaya dan universitas yang lain yang saya tahu sering bekerja sama. Karena PHT yang ada sekarang itu terlalu menjadi milik Departemen Proteksi Tanaman saja atau orang ilmu hama dan penyakit tanaman saja. Jadi fokusnya itu pada taktik untuk menekan hama dan mengurangi kerusakan tanaman. Dan sedikit sekali upaya untuk menjawab mengapa agrosistem begitu rentan terhadap politik. Kenapa kok diserang terus? Dan bagaimana membuat agar agroekosistem lebih tangguh terhadap serangan. Nah, sekarang ini kesadaran itu sudah ada. Ini ada nama Pak Gatot Mujiono itu karena saya sudah minta izin beliau bahwa slide-nya saya bajak, saya pakai di sini, dan beliau mengizinkan. Di UGM sendiri, sekarang ini sedang berkembang juga itu. Untuk solusi jangka panjang masalah PT hanya dapat dicapai dengan restrukturisasi dan pengelolaan agrosistem untuk mengoptimalkan layanan ekologi atau agroecological services, dan itu namanya pendekatan agroekologi. Di UGM sebentar lagi Pak Andi Tisol dan kawan-kawan akan menerbitkan buku Inpres sekarang ini yang bukunya berjudul agroekologi. Itu adalah bukan bagian dari PHT, tetapi evolusi yang lebih muntakhir daripada cara pandang PHT tadi. Di IPB juga mata kuliah agroekologi itu menjadi mata kuliah penciri Departemen Proteksi Tanaman, dan itu ditawarkan kepada jurusan yang lain. Bukan dari, jadi agroekologi menjadi mata. Jadi kalau ingat yang tadi, mohon maaf. Kalau ingat yang tadi, pengetahuannya itu agroekologi dipahami, dan ecological engineering itu adalah bentuk praktek dari ilmu yang disebut agroekologi. Yang saya katakan tadi bahwa teman-teman di UGM sedang menulis buku tentang agroekologi. Di IPB itu sudah dijadikan penciri dari proteksi tanaman dan menjadi kuliah khusus dengan 3 kredit kalau nggak salah. Dan sudah mulai di sini sudah 3 semester diberikan. Pak Gatot mempraktekannya di lapang di Brawijaya. Jadi ecological engineering semacam ini. Jadi ini bentuk, kalau tadi ini PHT, 3 trophic level dan lain-lain, ini lebih banyak ke landscape. Ini pengertian agroekologi, mohon maaf bukan menggurui ini saya ambil tadi, saya bajak dari PPT-nya Pak Gatot dari Brawijaya, dan atas izin beliau ini bisa dipaparkan secara utuh. Tidak. Jadi menurut yang ditulis pada PPT itu, agroekologi adalah ilmu yang mempelajari agroekosistem secara holistik, menyeluruh dan keterkaitan bagian-bagiannya, dalam hal ini termasuk semua unsur lingkungan dan manusia. Suatu lahan pertanian dipandang sebagai sistem yang kompleks di mana proses ekologi berlangsung dalam kondisi alam. Jadi itu, jadi agroekologi adalah ilmu yang mempelajari bagaimana merancang dan mengelola agroekosistem yang berkelanjutan, lalu penerapan prinsip-prinsip ekologi untuk merancang dan mengelola agroekosistem yang berkelanjutan. Ada suara anak kecil manis sekali. Jadi rekayasa ekologi dan pengelolaan rekayasa ekologi dan pengelolaan ekosistem yang dilakukan itu memadukan pengelolaan tanaman terpadu. Nanti ini ada bagaimana tanaman pemecah angin, landscape, penataan landscape, ada pengelolaan tanah terpadu, integrated soil management, dan ada PHT biointensif. Nah, PHT biointensif ini banyak digeluti di Departemen Proteksi Tanaman IPB. Jadi meneliti PGPR, Simbion, Indofit, serangga-serangga mikroorganisme berguna dan lain-lain. Nah, yang terpenting dari rekayasa ekologis pengelolaan agroekosistem itu skala unit manajemennya beda. Ini unit manajemennya landscape. Siklusnya juga hanya tidak 1 musim atau mingguan, tapi siklus tahunan, dan memerlukan kelembagaan. Jadi susah. Jadi kalau kita lihat tadi apa yang di sana, itu hanya bagian kecil komponen-komponen dari rekayasa ekologis pada tanaman padi. Kalau rekayasa ekologis yang benar, itu mulai dari penataan landscape. Nah, ini hambatannya banyak, tapi juga banyak tantangan. Yang terutama ini tantangan yang sekarang ini zaman IT dan itu bisa menjadi semuanya seolah-olah bisa ditangani pakai IT dan perkembangan teknologi itu sangat luar biasa. Selain IT juga nanoteknologi, bioteknologi, sehingga itu merubah cara kita nanti bekerja di lapangan. Sebagai contoh, kalau dulu kita mengidentifikasi serangga itu berdasarkan morfologi, berapa ini, venasi sayap. Sekarang itu tidak sesulit itu, tinggal membuat preparat, dikirimkan, lalu dengan marker genetik kita bisa ketemu. Makanya terus ada istilah kalau sekarang ini, padahal kita dulu sudah nyebutnya spesies, morfospesies, jadi spesies yang diidentifikasi berdasarkan morfologi. Belum molekuler itu, nggak canggih kan. Jadi sekarang ada teori itu. Cara pengamatan, kalau dulu pengamatan langsung, sekarang pakai satelit. Semuanya bisa diatur. Jadi kedepannya nanti, saya kira pengamat hama, peran lulusan ilmu hama dan penyakit tanaman, itu tidak akan melulu seperti dulu lagi. Jadi harus dikuatkan dengan teknologi penginderaan jarak jauh, analisa spektral, karena sekarang dari apps yang kita ciptakan saja kita sudah tidak hanya bisa memantau penyakit apa dari spektralnya, tapi dari jauh ya, ini keserang orang atau kekeringan atau keserang tikus itu bisa dari jauh, atau keserang penyakit apa bisa dari jauh. Tapi juga sampai dengan mengidentifikasi kekurangan hara bagaimana. Nah, itu kadang-kadang bagi orang-orang kuno kayak saya itu merasa nggak mungkin, seperti juga kalau kita mengidentifikasi tanpa melihat morfologi itu nggak mungkin. Nah, saya termasuk orang kuno. Yang kedua, selain itu juga IT ini juga berpengaruh terhadap bagaimana kita berkomunikasi dan membangun kelembagaan. Kalau revolusi hijau dulu semuanya satu arah, petani harus ikut, kalau nggak ikut ditangkap. Lalu ada PHT, ada pendekatan partisipatoris, bisa saling diskusi. Nah, pertanian 4.0 itu nanti bagaimana? Siapa yang akan mengarahkan sehingga pendekatan agroekologi bisa dijalankan? Nah, ini yang paling susah. Yang paling susah itu masalah kelembagaan di pendukung petani. Jadi kalau kita bisa berpikir agroekologi, tapi kendaraan yang ada itu mungkin cara pikirnya masih cara pikir level pertama tadi, yang satu traffic level, mungkin level kedua, mungkin level ketiga. Dan itu terjadi, terus terang saja terjadi. Kritik saya terhadap Kementerian Pertanian misalnya, ketika mereka gagal paham apa yang dimaksud dengan statement Presiden tiada hari tanpa panen di Indonesia. Presiden menekankan panennya. Karena kalau mau panen itu pakai pendekatan agroekologi. PHT paling enggak versi yang ketiga. Tapi jadi dengan demikian kalau kita panen baik di Indonesia mesti tiada hari tanpa panen, karena panen bulan 1 mungkin ada di satu daerah lain, bulan kedua di daerah lain, bulan ketiga di daerah lain, sehingga di Indonesia itu unitnya Indonesia, sehingga di Indonesia tiada hari tanpa panen. Problemnya sekarang adalah bagaimana penataan logistik, makanya ada tol laut dan lain-lain, jadi bisa dilakukan. Tapi kalau cara pikir itu dipakai oleh level yang satu trophic level atau dua trophic level yang tadi, terjemahannya jadi lain, dan itu sudah terjadi dan sekarang akan terjadi lagi. Kritik saya mungkin juga timbulnya hama wereng dan hama-hama yang lain dan turunnya produksi itu bukan karena OPT, itu lebih banyak karena policy yang kurang tepat. Jadi kita pernah dengar ada bahwa di suatu daerah itu harus tiada hari tanpa panen. Bisa didorong yang biasanya 2 kali panen menjadi 3 kali, bahkan 4 kali, yang justru bertentangan dengan prinsip agroekologi. Kalau dulu orang pegawai pertanian, mohon maaf, rapat di Jakarta yang ditanya berapa tambah luas tanam, berapa begitu. Jadi yang stres petaninya di lapang karena banyak gangguan dan itu sejarah berulang. Saat ini juga ada keinginan semacam itu, tapi kita berusaha untuk meluruskan supaya pandangan Indonesia itu, ini sekali lagi adalah skill dari skala pengelolaan, jangan di skala Indonesia, jangan diterapkan di desa, kecamatan, atau kabupaten. Itu hancur itu pendekatan agroekologinya dan akan bertentangan dengan alam. Nah, ini yang terakhir ini. Bagaimana supaya agroekologi nanti bisa jalan? Saya percaya betul pada ilmuwan-ilmuwan muda, anak-anak muda yang sekarang, yang saya kira kecerdasannya itu beda dengan saya atau generasi yang lebih tua. Jadi mereka itu paling tidak berani berpikir nyeleneh, berani menanggung risiko, dan tidak takut letih. Jadi kalau kayak saya itu kayaknya berpikir nyeleneh itu agak gimana begitu ya, apalagi menanggung risiko, dan karena tua cepat capek. Jadi untuk anak-anak muda ini saya akan berharap akan ketemu. Nah, ini mohon maaf ini, jadi saya lihat di Departemen Hama dan Penyakit Tanaman itu anak dosen-dosen mudanya, dokter-dokternya banyak sekali, berasal dari mana-mana. Saya kira itu nanti akan mengembangkan ilmu-ilmu baru yang harus di luar jalur, ini mahasiswanya juga ini, di luar jalur yang kita tempuh dulu. Kalau saya dulu kan tempuhnya begini, sampai pada tahap ini, dengan segala macam, dengan IPM, dengan apa. Nah, kita juga masih bisa nolong teman-teman itu, tapi tidak harus memaksa yang muda-muda ikut dengan kita lewat jalur ini loh. Ya kita mesti memberikan tangga gitu. Dan saya yakin bahwa mereka menggunakan tangga itu bukan untuk ke jalan kita, tapi membuat bangunan baru memakai tangga, dan memakai tangga itu menyambung. Jadi saya berharap nanti ke depannya dengan penelitian-penelitian misalnya untuk teman-teman hama dan penyakit tumbuhan mulai memikirkan penelitian kaitannya dengan windbreaker, tanaman refugia, macam-macam yang tidak pernah kita pikir sebelumnya, yang hanya berpikir satu atau dua trofoplankton. Tapi ini sudah ada konsep-konsepnya, sudah sampai ikut di komunitas. Kembali ke yang awal tadi, slide-slide itu menjadi bagian-bagian kecil mengarah ke pendekatan rekayasa ekologi. Dan itu bisa jadikan pintu masuk sebelum yang lain-lain dilakukan. Jadi kita bisa masuk dari pengendalian biologi, pengumpulan kelompok telur, nanti ditambahi lagi dengan pengembalian jerami, ditambahin lagi dengan tanaman refugia, itu pun hanya di sawah kita sendiri. Nanti dengan tetangga-tetangga, akhirnya kita nanti sepakat kalau dengan Pak Gatot Mujiono, bagaimana kita mengembangkan sistem agroekologi berbasis padi, tapi ada juga dipikirkan pola tanam dan lain-lain yang secara keseluruhan untuk kesejahteraan petani Indonesia. Saya kira itu yang bisa saya sampaikan. Mohon maaf kalau ada salah-salah kata. Sangat gembira sekali bisa berbagi dengan kolega-kolega di Universitas Andalas kepada adik-adik mahasiswa. Saat ini di IPB, UGM dan lain-lain, konsentrasi penelitiannya banyak di sana, termasuk nanti kalau di Universitas Andalas juga teman-teman HPT juga harus memperhatikan kelembagaan petani yang harusnya tidak dilarang kepada penelitian partisipatif petani yang kurang bermutu dari sisi yang lain, tetapi mungkin yang bagus. Saya percaya teman-teman akan bisa lebih baik daripada kami-kami yang sudah tua. Anak-anak muda saya berharap banyak. Saya kira gitu, mohon maaf kalau ada salah-salah kata. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bapak Hermanu yang sudah presentasi dengan sangat bagus sekali untuk menambah wawasan kita semua tentang ecological engineering. Ini
Bu
kebetulan
Miss,
ya,
ini sedikit saya potong ya. Tadi Pak Hermanu bercerita atau menyebut nama Pak Joni tadi, Pak Insinyur Joni. Jadi saya sengaja telepon beliau dan beliau juga udah bergabung bersama kita nih, Pak Hermanu. Temannya Pak Hermanu.
Terima kasih Pak Joni, itu guru saya, guru di lapangan. Jadi
selamat datang Pak Joni.
Pak Joni,
Teman lama ini Pak.
pahlawan kita tuh.
Ya nanti
aktif tuh Pak, video sama audionya Pak Joni tuh Pak.
Oh, masih di mute ya?
mungkin nanti bisa diminta juga pengalaman Pak Joni untuk rekayasa.
Sangat diminta.
Nah, ini beliau Bu.
Ya, selamat datang Pak
Ya,
Joni.
Bos.
Selamat datang.
Ini ada teman lamanya nih Pak. Bukan teman lamanya, teman yang sampai sekarang masih teman ya Pak.
Sehat lah. Alhamdulillah lihat sehat Bung Joni.
Ya tadi saya sedang di jalan, di kontaknya oleh Pak Dekan kita. Tolong ikut nih Pak Joni. Itu aja tadi. Ngapain apa mau diikut? Nah itu lupa ketemu teman lama saya. Selamat pagi Pak Prof. Hermanu.
Selamat pagi Bung. Sehat-sehat ya. Yang penting itu senang lihat kesehatannya, senang. Itu yang penting bagi kita sekarang.
Saya memang sehari-hari ngurus tani aja Pak. Sekarang.
Alhamdulillah. Ya.
Baik Pak Joni, nanti akan kita berikan waktu untuk Pak Joni untuk juga. Kemudian tahun 2018 saya pernah ke Bogor Pak Hermanu menceritakan adanya serangan wereng di Sumatera Barat. Waktu itu saya pernah bertanya sama Pak Hermanu, kenapa kisah wereng ini nggak masuk dalam datanya Pak Hermanu gitu ya? Mungkin Bapak nggak ingat kali ya. Karena dalam data Pak Hermanu nggak ada Sumatera Baratnya gitu. Oke, saya interested what you mentioned before Pak Hermanu that farmers sometimes better than campus in cultivation, right? Dan saya tahu Bapak ini sangat dekat dengan petani ya. And for the second presenter, Dr. Rafi, are you here now? Dr. Rafi?
Yes, I'm here.
Thank you very much for coming.
Yeah, thank you. I just arrived from the hospital. Yeah.
Yeah, thank you very much for coming. Even though you are feeling sick now.
No, I had my checkup. I had my COVID test, so it's negative.
Okay.
Yeah. Also for my son and my wife, also. So everybody negative.
Okay. Good luck. Glad to hear that.
Yeah.
Okay. Congrats.
Thank you.
Yes. Okay. For second presenter, I cordially invite Dr. Rafindra Joshi from Philippine Rice Research Institute. But wait a while, I will share screen for introduce Dr. Rafi for you all participants. Okay. Dr. Rafindra Joshi, sorry. From Philippine Rice Research Institute, bachelor degree in the field of agriculture, India, and master degree in the field of entomology from Tamil Nadu Agriculture University, India, and the PhD focus on entomology from University of Philippines at Los Baños, UPLB, Philippines. He lives in Philippines now, but actually he come from India. From his curriculum vitae that I hold now, he has many experiences in research collaboration, consultant, advisor related to integrated crop management on invasive species like golden apple snail, biodiversity loss, and others. He has experiences for more than 25 years. So, Dr. Rafi, thank you for coming. Please you share your screen and time is yours.
Just a minute. Thank you so much. I'll just share my screen first. Can you see my screen?
Yes, I see.
Is it clear?
Clear, very clear.
Wait a minute. Yeah. How about now?
Clear, Dr. Rafi.
Very good. Very good. Okay. First of all, good morning to everybody. I would like to first of all thank the moderator, Dr. Shara Rawati, for the kind introduction. I'm sorry, the names are quite difficult. I would also like to thank the Dean of College of Agriculture from Andalus University, Dr. Busnai, for the kind invitation, and to the head of the Plant Protection, Pest and Disease Department, Professor Dr. Noor Balias. Thank you so much for giving me this opportunity for sharing our experience on ecological engineering. Also would like to thank the speaker ahead of me, who was very kind enough to make the presentation while I was still in the hospital for a checkup. So thank you, Dr. Tri V. Dodo, for taking my place, so that we could continue with this important webinar. Yeah, I had a quick, I was looking at the slides of the earlier speaker, and I think he has covered a lot of basic things, though it was in Indonesian, but I could understand, being a scientist, he talked a lot about ecological engineering. So what I'm going to do today is to share with you our experience on ecological engineering for the rice pest management. So mostly my presentation would be around maybe 45 minutes. The structure of my presentation is I will give a global rice production system, a little information about sustainable pest management, what is the need for it, for selected invasive rice pests. I'll deal with pests that are very important for Indonesia, as well as to the other ASEAN countries like Vietnam, Cambodia, where we have been working with all these three major pests. One is the rice plant hoppers, where Indonesia is famous for, introduction of the IPM approaches for rice plant hoppers. In the early 1980s, while I was still with IRI, there was a lot of good work done by the Indonesia. The second is about the rice field rats, which is very important also in Indonesia and in many rice growing countries of the ASEAN region. And third is the invasive golden apple snail. Now we call it invasive. We do not call it golden apple snail because there are a lot of confusion in terms of which snails are we talking about. Then the second aspect that I will talk about is very basic about the introduction to ecological engineering, especially in rice pest management. So what is ecological engineering? What is the philosophy of ecology? And what are the ecological engineering for pest management? And of course, a little about the description of the foundation or the pillars of ecological engineering. and then the examples of selected invasive species, and a take-home message at the end of my presentation. So as you know, rice is a staple food for more than 2 billion people in the world, and much more is needed to, higher yields are needed, because to keep up with the global increase in demand, which is around 62% in the next 25 years, because of the increase of population growth, as well as the rice area cannot be increased anymore. Therefore, the rice production systems are going, intensification, involving simplification of the landscapes and increased inputs of fertilizers and pesticides. So in addition to this problem, we have a global climate change is favoring the, the spread of many kinds of pests, including diseases, rats, snails, and insects. And this is causing, because this is causing, the misuse of and abuse of pesticides in many parts of the world. And this is also leading to the environmental problems, as well as the problems that relate to the farmers' health, and besides killing the natural enemies of the pest. The losses caused by insects because of the climate change and because of the intensification is ranging from 25 to 100%, depending on the crop. Some crops, they compensate losses better than the others, and and these losses also depends on the area, as well as the country, and as well as the farmers' practices. So it is therefore very critical that the production system, including the management of the pests, has to become sustainable and ecologically acceptable, ecologically sound in the changing climate. This is the basis of the ecological sustainable pest management, which is ecological engineering that relies on the preventive strategies rather than the reactive strategies. So some of the interventions are bio-friendly or green plant protection methods that we use. And I'll be talking about some of those things that for the 3 selected invasive species, the rice plant hopper, the invasive apple snails in transplanted rice, and of course the rice field rats management system that we have developed through many years of our work. Please understand that all of my slides, there is a link below, so you don't have to worry. You can go to the link and you can look at after our webinar. So the links are available for you to get more information aside from what I'm going to talk about today. So as you know, plant hoppers outbreaks is increasing, both for brown plant hopper as well as the white-back plant hoppers on thousands of hectares, causing millions of dollars in loss because of the use of susceptible hybrid rice varieties. Many of the hybrid rice varieties, based on our work before in my early days in the Philippine Rice Research Institute, I looked at how hybrid rice and inbred rice, the plant hoppers will be a problem or will it not be a problem. So what we found out very interesting in these cases is that many of the white-black plant hoppers are becoming, they are occupying more niche than the brown plant hoppers in many of the hybrid rice systems. So that's why even today you look at it in many countries, you have more problems of white-black plant hoppers in hybrid rice systems compared to the inbred rice systems. And the second thing that we have observed is because of the increase in temperature, the global temperature, and because of the use of high use of fertilizers and broad spectrum insecticide, it's causing hopper burns and even hopper storms. If you look at the picture on the right-hand side, the picture that you usually see nowadays whenever you are going to the restaurants or or sitting outside or out of your house, you can see in certain periods of the year, you get a lot of these hoppers coming to the light. So we call them hopper storms. The second pest that I would talk about is the rice field rat. I think this is one of the most chronic problems that farmers encounter every year and every season. In Asia, we know that the rodent cause around 5 to 10% losses. And this 5% loss actually approximate to 30 million tons of rice, which is good to feed around 180 million people for the next 12 months. So, you know, the impact of rat damage is very serious, especially because they are a pest which starts right at the seed bed to the transplanted rice, to the maximum delivery, and even until you have harvested the rice, the rats become a problem in the storehouses. So they are a pest. This is one pest which is present throughout throughout the year, whether they are in the field or after harvest, whether there are problems in the storage areas. The third important thing, which is the problem that we observe and which is still continuing to be a very serious problem, especially in the current time, is because of the increased flooding. And this is the invasive apple snail. You know, I've been working on invasive apple snails since the first time it came to the Philippines in 1987. And since that time, I have been working with many countries on invasive apple snail. So you can see a map here of different countries. And these are the countries I have currently have networks in all these countries where we are extensively working on invasive apple snails. And the invasive apple snail is considered as 100 worst invasive alien species. This is from the IUCN and the International Union for Conservation of Nature and the Invasive Species Global Database. They use the term in the olden days is the golden apple snail, but there the problem is we are not dealing with one species of apple snail. We are dealing with more than 2 apple snails in most of the Southeast Asian countries in the ASEAN region. The problems of snails are actually 3 kinds of problem. One is they cause a lot of loss, especially with the increased flooding. And you can see globally, they are causing a loss of around 55 to 248 billion per year. Second important thing, you know, many farmers, many field workers in Philippines and even in other Asian countries, they do not have any protective clothing. They do not have shoes. So, you know, these snails, they are carriers of the rat lungworm parasite. You see the nematode that is on the left-hand side, the last photo. And this shows that this nematode is a major health problem that is causing the farmers. And recently now we are working extensively with a lot of countries, including with the University of Hawaii, on looking at the infestation of this rat lungworm parasite in many of the Asian countries, and including in the countries where the snails have invaded. The third is the problem of the spraying. It's also causing a lot of health hazards. In the past, there was a lot of problems with the organotic compounds. So, you know, the animals, the farmers, they used to lose their nails from their toes and in the hand. But those compounds, because of our work, those compounds cannot be used anymore, and they are already banned. The second thing that we have recently found for the last few years, that in direct seeded rice, when you spray chemicals like niclosamide, which is a very, very common chemical, which is used in almost all the Asian countries because it is fast acting and it is farmers see it very effective. because this is causing the problems of the establishment of direct seeded rice. You look at the roots of the untreated fields are much longer and the seedling height is much higher. Whereas in the treated fields with the closamide, this is causing retardation and is also causing the plant to get exposed for a longer time for the snail damage, because the snails usually prefer younger plants. So the economic, health, and environmental problems that are caused by the invasion or by the apple snail are irreversible, and the cost is very enormous. So what is ecological engineering? You know, this is very, very interesting topic, which actually, you know, it's only now its importance has been realized, but it was as early as in 1962, Odom, who was a famous ecologist, he actually used the term ecological engineering. He was the one who coined the term because to deliberate manipulation of the habitat to benefit for the benefit of the society and natural environment. So in simple terms, ecological engineering is a human activity that modifies the environment according to the ecological principles, thereby enhancing resilience and sustainability of farming systems. So in short, ecological engineering is all about how do you manipulate farm habitats, making them less favorable for the pest and more attractive to the beneficial organism. So beneficial organisms, you know, in the earlier presentation, they were also shown the ecosystem landscape, where the presenter has shown decomposers, the natural enemies. So these are benefit to the beneficial organism. So ecological engineering is a new direction for management of agricultural pests by increasing the abundance, diversity, and functions of natural enemies in agricultural ecosystems by providing refuge and alternate or supplementary food sources. It also reduces the herbivore damage by providing resources for natural enemies. So what are the culture? Mostly the focus of the ecological engineering is to manipulate the habitat by using, you know, the cultural techniques that farmers are using for many years. So if you look at in the olden days, you know, I still remember when I was a small school, high school student, I see my grandfathers and my ancestors and the other villagers in my village. You know, they used to use a lot of cultural techniques, like, you know, they used to have a lot of flowers, planting flowers near the fields, near their house, which is in the same area where the fields are there, where the crops are going. So, you know, now we are trying to understand what they were used to do. They were actually using the ecological engineering principles, but at that time that term was not coined, but they used different cultural techniques to manage ecosystems health as well as their production systems. But they were doing it, and now we are putting a scientific basis to what they were actually doing. So ecological engineering, as I said, is going to use a lot of different cultural techniques. So I've listed a lot of techniques that are going to be shown here. And these are actually currently the FAO agroecological principles. The agroecological principles are actually based, and ecological engineering, the system for rice intensification like SRI, are the ecological engineering techniques that are used to manage crop production and crop pest management practices. So in ecological engineering, there are two things. One, you restore the biodiversity, and secondly is to conserve the biodiversity. So you can restore biodiversity by using different techniques, like, you know, instead of growing a single crop of rice, you have crop diversification. You grow different kinds of crop in an area to increase the diversity of the varieties. And also you plant, the people are now planting this ecological engineering. I'll show you in other countries how it has benefited, especially planting of nectar flowers around the bunds or around the fields. And the second is to reduce the use of insecticide. You know, we have done a lot of work with many countries, because when I was working with Erie and also with field rice, we are promoting that we should not be spraying for the first 30 days, for the first 40 days. Basically, because now we understand that the rice crop has a lot of compensation ability. It has the compensation to recover from insect damage or disease damage. The second is avoiding using insecticides to prevent the kill of beneficial organisms, which are important for many people. So the second, both of these techniques, the restoration and the conservation technique of biodiversity, helps in the species biodiversity. You know, parasitoids, predators like wasps, beetles, ladybird beetle, and other kind of predators like spiders, decompositors like, you know, what was the earlier columbolans that was shown in the earlier presentation, and even the soil organisms. And these species diversity improves the ecosystem functions, especially for pollinators, for parasitism, and for predation. And then the ecosystem services like reduction of pest invasions and regulation. So if you see on the slide, on the right hand side of the slide, the first photo shows, you know, many of these farmers are growing string long beans, which is very common, whether in Indonesia or Philippines or China or Vietnam. They usually grow this for along the side of the bunds. The second is also there now a lot of these different kind of these kinds of soybeans or other leguminous crops. They are being planted in China and in other countries along the side of the rice field. And the third is reduction in the use of pesticides. So in the rice ecological engineering, especially for the rice pest management, the first scientist who actually introduced or demonstrated this broad application of ecological engineering was Dr. Jeff Gurr. He's an Australian. And, you know, Erie has been working very closely with Dr. Jeff. And, you know, he was the first person. We had a multi-country study in many countries in the early 2016, in the early years of 2000. And, you know, there we have shown how the increase of abundance of parasites and parasitoids of the principal rice pest, basically because we at that time looked more on plant hoppers and the rice leaf folder, which is also a serious problem in the Philippines. Now, the ecological methods that are being used are, you know, vegetable strips or fowl strips, as I showed you before, marigold, which is very old practice, sweet basil, which is also very old practice. Usually biocontrol people, they know about the value of these, and especially they act as a repellent plant. Like say, for example, for the control of nematodes, yeah, they are using a lot of marigold. For sweet basil, mostly to encourage Hymenopterous parasitoids and other predators. Then there are attractant crops. There are other kind of techniques which are listed here. So this is some of the techniques you see there. You have a main crop example here, and you have a trap crop around there. This is what we are using in rice to manage rats, using the trap barrier system, which I will show you a little later. And this is the second, the same thing. You see, this is a rice crop, and this is the trap barrier, the young rice crop that is grown around there, much ahead of the main crop with the trap barrier system. The second is the strip crop, trap cropping. And then there are other techniques, like say, for example, you have mustard, and then you have this crucifer, this ball cabbage. So you attract the diamond black moth to the trap crop, kill, you can get rid of the in the trap crop. You can manage the DBM, the diamond black moth on the trap crop, and so that you will have less problems of diamond black moth on the main crop, which has more profit to the farmers. This is a typical example of which we are using, many countries are now using, is a vertical grass. I think everybody knows in many of the countries where vertical grass is usually grown for, prevent erosion, prevent, because of the flooding. So vertical grass, and even in the slopy lands, to prevent degradation of the soils. So this vertical grass, what we have found out is that it is a very good attractant. So what happens, stem borers, they come and lay eggs on the vertical grass instead of the rice, because they prefer vertical grass has some kind of compounds. So vertical grass is a trap crop, which is actually like, it pulls the stem borers to eat. So the stem borers, they lay their eggs there. So once the eggs are laid, they hatch, and then they cannot, the larva is unable to survive because of certain compounds that are present in the vertical grass. So the stem borers, they have a natural death. So you have less damage to the rice crop. So this is something like research which is now widely used for ecological engineering in Vietnam, China, and also we are using this in the Philippines. So there are three pillars in ecological engineering. The main is to maximize the natural biological control services, which I have actually explained in my earlier slide. We want to increase the biodiversity and the abundance of the natural enemy community. So in the first plank that I mentioned is, and which I've shown in the earlier slides, is to prevent early season sprays for the first 40 days. The second is we build up the predators on the detrivore prey. The detrivore preys are like, chironomids and other, which are neither, I can say, harmful, nor they are beneficial to rice, but they are beneficial. Excuse me, there's somebody talking. Hello.
Pesawatnya rusak.
Pak Dekan, tolong matikan sedikit.
And the third plank is the enhancement of the parasites and predators. So this is what I have shown in the three foundation. So this is the first one. So if you reduce the early application of insecticides, you reduce the problem of, you control the leaf hoppers to around 86.5%, but you reduce you did not control leaf hoppers, then you have, but if you control leaf hoppers, then you get a problem of plant hoppers to almost tenfold. So what happens is that early application of insecticides is causing a problem in the resurgence of other pests. So this is on the right hand side, you will see a graph. And this is my PhD work in 1980s. And until today, all of this is being widely used, because I have shown in the field that if you have a resistant variety and a susceptible variety, and you spray insecticides whether it is a resistant variety or is susceptible, you spray it for brown plant hopper in the early days, that is around 10 days after transplanting, you will get a hopper burn on the 35th day. So this is what I'm saying. So what happens, you can see the spiders, they drastically decreased in the spray treatment, as well as the hopper population exploded in the at the around 35th day after the application of insecticides. The second is to build up on the detrivore sprays. These are neutral animals that, what I mean, so they are like columbolans, the chironomids and all that. They are widely present in the rice field, especially during the start of the season. So this is just to show the rice ecosystem food web. This is the aquatic habitat, the crop habitat, and the non-rice habitat. You know, many times we can try to control the many of these pests on the crop habitat, but we do not look at what is happening in the non-rice habitat, which has a big influence on the management of the pest in the rice habitat, as well as in the past, you know, very little work has been done on looking at what is happening in the aquatic habitat and the non-rice habitat to maintain ecosystems. And the first work that has widely been used, work by Bill Settle from FAO, he did a lot of work in Indonesia on looking at these aspects together with Dr. Kevin Gallagher, formerly with FAO also, on the importance of the aquatic habitats and the non-rice habitats to manage the invasives, to manage the rice pest. The third one is the enhancements of the natural enemies. And I was telling you, like in China, they are growing, you know, sesame plants, which have a lot of flowers. They are rich in nectars to improve the efficiency or to increase the abundance and biodiversity of the natural enemies. And what we have also found in the Philippines as well as in China and in other countries, including Vietnam, that if you have clean bunds, you have lower spider biodiversity. And you know, spiders are the major predators of rice pest in the rice ecosystem. In same thing in Vietnam, we have found that the bunds which have flowers, they have increased level of parasitism of plant hopper eggs. And same thing in case of Thailand, we have also seen that the fields that are surrounded by flowering plants have higher biodiversity of natural enemies and abundance of natural enemies. So this is a typical field in China. You can see the flowering plants, and this is the rice field. And then you have undisturbed habitats. You can see on the background the trees and the other vegetation. So I have talked about this in my earlier slides. So it's about habitat diversification, agro-ecosystem management, and if you have polyculture crops versus you know, single crop, then you have monoculture over polyculture has a lot of implications on ecological engineering. So these are in nutshell, in the what I've shown is in the three habitats, you have parasitoids. The main job is to regulate and what are the good agricultural practices that has to be followed to enhance parasitoids, predators. And about the detrivores, which earlier speaker has talked about, is the Colombians, the airfit flies. They are helping in nutrient cycling as well as in the organic matter. So they are supporting, their job is supporting the agro-ecosystem. And the third one is the earthworms, the termites, the millipedes that are usually in the healthy ecosystems, and they are again supporting. So the parasites and predators are regulating, whereas the detrivores and the soil ecosystem engineers, they are supporting the ecosystem services. So this is above ground, and then which I've already talked about it. And the second is the below ground, that is, you know, earthworms, detritivores, and the mycorrhiza and other things that enhance biodiversity as well as uh, this one. So in the Philippines, Dr. K.R. Yong, who is a Malaysian, who has been with IRRI for many years, is retired now, but he continues to work in other countries, in China and other countries, on ecological engineering. So he was actually the first person who introduced ecological engineering in the Asian countries in 2008. And he was my postdoctoral mentor, and so we worked very closely in the early days with him on the ecological engineering. So the first experiments were conducted in China in 2009, and then they were followed by Vietnam, Thailand, Philippines, Malaysia, and now I think also in Indonesia, there are some work that is going on in some universities. This is the main ecological pest management in nutshell. Is the main important goal of the ecological pest management or ecological engineering is to maintain healthy plants from root to foliage. So, in the past, like in SRI, we are looking at the system for rice intensification. We are looking at more on the root health rather than, because the root health dictates the health of the foliage. So you should, that's why in SRI technique, and SRI is widely, Indonesia is one of the countries in the region that have the highest promotion of SRI. And then in India also SRI is widely practiced. So the ecological principles, the ecological engineering principles are actually, the ecological engineering principles are used also in SRI, which actually pest management are also one of the principles in SRI. So this is a typical example. I'm repeating again some of the ecological demonstrations that were first done in China. So you can see there was a trap crop on the side, and there was a sesame along the bunch, and then there is a zizania also on the other side. So this is a typical example of rice plant hoppers, which I was showing you is a very serious problem. So these are sesame plants which are grown on the side. So planting flowering plants to provide nectar to parasitoids and predators. Sesame is planted on the bunds on the rice side before rice transplanting, and few months after 1 month of rice planting to ensure sesame flowers are present. So they provide the food for the natural enemies while the pest is still coming in. So what we have found out that the egg parasitism was higher by 45% in fields that has sesame flowers compared to, and then the hopper densities decrease, population decrease by 30%. This is what is also shown in the graph on the right hand side. So with flowers and without flowers, that means, and the same in terms of both the brown plant hopper as well as the white back plant hopper. So this is an excellent technique. And during my postdoctoral work before, I have found out a lot of natural enemies like anagras, the Hymenopterus parasites, and the other predators. They are usually they are present on other alternate hosts along the side of the bands. So that was my postdoctoral work that I did in IRRI, that we were able to find that this increased a lot of reduction in the plant hopper problems. This is a perennial grass that I was telling you, the zizania, which is usually growing along the rice fields, not only in China but also in other countries, and they provide an important alternate host for the parasites and predators during the periods of when the rice plant hoppers are still not available. And I talked about the egg parasite, which is a very important parasite, and also about which is usually present which is a major parasite of plant hoppers, but it also attacks other kind of plant hoppers that are found in this grass. So, you know, when the brown plant hopper comes in, they move to the, so this diagrammatic, the second in the middle, is showing the movement of natural enemies in 3 habitats. So this is a non-rice habitat, the rice habitat, and the aquatic habitats. So there is a lot of movement that is going not only during the day, but as well as during the night, because I have seen in my work, in the night, the crickets, they move from the non-rice areas to the rice areas. And in the daytime, they are taking shelter in the non-rice habitat. These are some of the flowering plants. You don't have to only have, you know, the flowering. You can also use other leguminous crops or other families of the cultivated crops to use as plant for nectar. This is the example I showed about the stem borer in China before, that how the vertical grass help in managing, in reducing the damage to rice stem borers in rice. This is a multi-country, multi-year project. You know, Bangladesh is doing a lot of work, and you know, in Philippines, a lot of work has been done by my former colleagues, and they have looked at what are the positive as well as the negative impacts of some of the ecological engineering work. So this is a work in progress, and you know, over time we are improving a lot of research on it. One of the examples I want to also show you, that sometime with the ecological engineering we have seen, especially when you do not have much destruction of non-rice habitat, the rat damage was high. So now we are also looking at that aspect of how to solve the problem of rat management. These are some of the ecological engineering practices that are followed in not only, this is in Indonesia, Java. My good friend, Mr. Jatika, who's doing a lot of work on SRI, and he is an organic person. And, you know, even the SAFE network, which is in the Andales University, of which Dr. Nobizar Nazir is the global coordinator, we are doing a lot of work on SRI, safe rice. We call it safe SRI rice in Bali, in Indonesia, with many universities there in Bali, especially the University of I'm not remembering the name. It's Varmadeva University. We are doing a lot of work with Varmadeva University there on SRI using the ecological principles. And these are some of the photos in different areas of the Philippines where this technology is now is being practiced by the farmers. So the second aspect I want to show is in the rat, how we are using this technique. You know, in the rat management, this we developed in Philippine Rice Research Institute, and this is now widely used. Even ERI has supported our work on this. We were the first people to start this project, where we developed ecologically rat management system. So our main purpose was, because we were spending around 3.5 million for the management of rat in our institute farm in the Philippine Rice Research Institute from 2004 to 2004. It's a lot of money for management of rat. So at that time, we had a very, reactive type of, we used to apply sustained baiting of chronic as well as acute rodenticides before planting, during planting, after planting. So we spend a lot of money. Then we introduced this technique called the trap barrier system plus the trap crop. So you can see there is a much older crop that is growing inside the plastic enclosure, and the younger crop outside, which is much, much young. So we are able to use a variety of rice, an aromatic variety of rice inside the trap crop to attract the rats before the farmers will start planting their rice. So we are able to reduce the reproduction of rats before the rice planting season by the farmers.
Dr. Rafi?
Yeah.
Excuse me.
Yeah.
Maybe you only 5 minutes more.
Okay, sure. I think I'll be done with that 5 minutes. I'm almost there. And this is how we have done. We have done the steps one. We have done the digitization. The second is we have understand the biology of the rat during the different stages of the crop, so that we know what actions to take at different stage of the crop. And the main impact of this work is that we were able to reduce 83% reduction in chronic and 94% reduction in acute rodenticide. And we came out with an excellent book. It's a global book. We have chapters from all the rat experts and from Erie and from others. And this book you can download for free of cost on the internet. And the link is to the book is provided, as well as all the information on how we did this and how successful it is widely used by the farmers. The last one is the invasive apple snail. We have developed a technique where we are able to reduce completely the use of chemicals by our technique. So these are some of the techniques that we have developed using the ecological engineering principles. And now farmers, they do not apply a single chemical for transplanted rice. But for direct seeded rice, we are still developing a technique on how to minimize the use of rodenticides. These are some of the publication. Again, all of this book is the latest book on the right-hand side on the extreme, the biology and management of invasive apple snail. This is a global book. There are chapters from all over the countries, and including the earlier book, where there is a chapter also from Indonesia in the earlier book on the invasive. And now recently we have come out with the country reports from all the ASEAN countries. We have a report from Indonesia, from Myanmar, from Malaysia, from, in Indonesia, from the India, from the Institute of Science in Bogor, the researchers from Bogor who are working on snails, they have contributed, and this is all published internationally. So the impacts and my take-home message, this is my last slide. The ecological engineering principle is an ongoing, for pest management is still ongoing. We need to do more of this research, and also we need to motivate farmers by using to adopt ecological engineering techniques using non-formal education techniques. And thank you so much for the presentation. And this presentation is a joint presentation from the Philippine Rice Research Institute and the SAFE Network Indonesia. Thank you so much for this opportunity.
Thank you very much, Dr. Rafi. It's very, very complete and valuable knowledge that you're sharing to us today. And in briefly speaking, I want to say that ecological engineering is preventive strategy than reactive strategy, less favorable for pests, more attractive to natural enemies, restore biodiversity and conserve. And you also suggest to grow flower and vegetables in rice plants, and also inform how to maintain that in rice field. Very good, very amazing. All participants, we have 20 minutes more for discussion. I invite you all to give some suggestions, response, or more information about that. And firstly, I want to see chat box, and after that, I will give opportunity to audience uh, questions directly. First, from the chat box from Nini, I think these questions addressed to Dr. Rafi. I have seen about vetiver grass. What you explain about what that function of vetiver grass in the research? This is the first question for Dr. Rafi.
Excuse me, can you repeat? There was some problem of the voice. Can you repeat it?
Okay. From the chat box, I have one question for you.
Yeah.
Yes, from Nini.
Okay.
He said, I have seen about vetiver grass.
Grass. Okay.
Vetiver grass.
Yeah.
What you explain about that?
Yeah.
What the function of vetiver grass in the research?
Okay. That's a very good question, because you know what is happening is that we have studied China and Philippines and other countries, especially for vitiger grass is along the, you can usually see it. Yeah, now it's widely promoted in China, because what is happening is that it attracts the stem borer stem borer adults to come and lay the grass or their eggs on the grass. So it is like an attractant. It attracts. There is certain kind of chemicals that are emitted by the vetiver grass that attracts the adults of stem borer to come and lay eggs, and they prefer, the stem borer prefer to lay eggs on the vetiver grass many times than the rice plant. So now, once the eggs are laid, they hatch. And once they hatch, usually the stem borers, they go inside the plant, and then there, because of that chemical that is present, the larva doesn't grow, it doesn't mold, it doesn't become to further instars, so it has a natural death. So the use of vetiver grass is to attract and kill the stem borer larva, so that you can reduce the reduction of stem borer damage in the main rice crop.
Okay, thank you very much, Dr. Rafi. The second question, yeah.
Bume?
Yeah, Pak Rasidin.
Yeah.
Okay.
Oh yeah, I have a question.
Please.
Okay, makasih Bu Mei. Good morning, Dr. Joshi. My question is directed to Dr. Joshi. Dr. Joshi, I am also UPLB alumni. Yeah. I got my PhD in 1984.
Okay.
I was there for 5 years. I worked with Dr. Thomas Masao.
Oh, okay.
Dr. Elisio Kadapan.
Oh, okay.
And my classmate is Dr. Joe Hernandez.
Okay.
Okay.
I know all of them.
Okay. Thank you. I was there before. I am a plum breeder.
Okay.
I am a plum breeder, but I am very happy to join you talking about ecological engineering in pest management.
Yeah.
Because our task right now, how to reduce the use of pesticide and then go back to the organic farming.
Okay.
That is our message. I think but varieties is still one of the important component in pest management, of course. Especially, I will be focused on rice plant hopper.
Okay.
Because this hopper is now very, what do you call it? Still very serious in West Sumatra.
Yeah.
Why? because we have limited number of varieties resistant to plant hopper.
Okay.
Why? Because in West Sumatra, we have special quality of rice.
Rice.
We are using an high amylose content rice, not low.
Right.
Another place, okay. So my question is that how is the development of breeding for or using resistant varieties? The importance of using resistant varieties in your pest management in field rice, field rice research. So how it is important. And then my second question is that before I was there, I was making my master's research is developing BPH biotype on different rice variety with different gene for resistance. So I was able to develop a new biotype by rearing the insect with different varieties. So my question is that how is the development of plant hopper biotype right now, and what is the progress of breeding for brown hopper resistant especially and ATD might be also at field rice. So this is two questions that I would like to hear from you. And then the next question is that because our approach in ecological engineering is not a distant, what I call recent, like using pesticide. So we need also to have something social engineering to adopt ecological engineering in pest management. So how is the social engineering that you experience in different countries in order to adopt the EE in pest management? Thank you very much, Dr. Yosi.
Thank you very much, Bapak Dr. Rashidin, and I'm sure Dr. Rafi can understand what.
Yeah. That is, I understand all the three questions very well because
Your
Professor Rashidin is very, very clear in asking those questions. You know, first of all, I want to tell you that all the names you mentioned, they are all my good friends. And, you know, Dr. Masaho and me, we worked together in Nigeria, in IITA, in Nigeria. He's a plant breeder. I'm a rice entomologist at IITA in Nigeria. So we work as a team, and Joe Hernandez and me work together in field rice. And Dr. Kadapan is also one of my very good friends. Unfortunately, Dr. Masaho and Dr. Kadapan have died.
Yeah.
So we are very good family friends until now. So the first question is about the rice breeding in field rice. You know, most of the varieties that are released by field rice, the Philippine are by the Philippine seed board approved varieties. And many of these varieties, they have resistance to most of the major insect pests, especially brown plant hopper, white back plant hopper, green leaf hopper, and stem borer. And also for the diseases, because this is a basic requirement before you can release any variety. So, you know, field rice is continuing the work. On this. The second is about the biotype thing that you mentioned about the bio. You know, this will take me a lot of discussion on this. You know what happens if you subject the field population to different varieties over time, just like, you know, now you say biotype, but nowadays we are not saying biotypes. We are saying populations because, you know, you can create because of the selection pressure, whether it is insecticide, whether it is resistant variety, you can produce populations that become resistant. It's a biological phenomena where you fight, where like today, you know, I had my I was having my test for my COVID. So, you know, I also thought if I am found positive, I will develop also, my body will also fight to survive. So it's the same in case of biotype problem. So, you know, whether we say insecticide resistant plant hopper or other plant hoppers, we will develop this over time. It's a biological phenomenon. The third one is about social engineering. That is very important. You know, we want to find out why some farmers do not like to practice ecological practices that we are promoting. So that is why in my last slide, you see, in my last slide, for social engineering, we have to promote the ecological engineering using non-scientific, like non-formal methods. Like, you know, we have dramas, you have TV programs, we have more of a social interaction rather than the actual research. So, you know, it's a social research, the social engineering is very crucial, and you are right in this. Thank you so much. I hope I've answered your questions.
Okay, thank you very much.
Yeah.
Thank you, Dr. Rafi. Thank you, Dr. Rafiki. And we go to the second question. It is addressed to Dr. Hermanu. There is one question for you at the chat box. Plankton Sironidae dan Colembola, ada lagi plankton yang lain musuh alami. Bagaimana syarat hidupnya? The question like that, Dr. Hermanu, are you still here?
Yes. Yes, thank you very much. First of all, I would like to thank the doctor.
From Herlina, Pak.
Okay, okay. First of all, I would like to thank the Dr. Joshi about the new information about all of the things associated with ecological engineering. I think we are on the same track about that one. Before answering from Bu Herlina, I think I would like to add of the for the question from Pak Rasidin. I think there is a long discussion about the role of the breeding program for the combating the rice pest, for example, that one. So most of our concern on an ecological perspective is that as long as we are not using the pesticide as selection pressure, we won't have any problem on plant hopper. So that's why the focus on BPH resistant variety should be like revise it for that one. From the presentation of Dr. Yosi, you see that whether it is resistant or non-resistant variety, if you apply insecticide in the earlier time of the rice plantation, before for several reasons, and for example, for the live folder or in Indonesian, in most cases, to combat rice stem borer. That's why in my earlier slide, first slide, I show that by conserving the natural enemy of stem borer while in the seeding stage, it's very useful to avoid pesticide application on early stage of the rice growth. Therefore, we can postpone or maybe prefer not using pesticide, then won't be any problem on brown hopper. That's why for the breeding, I think it is a long way we have not mentioning about the biotype on the ecological engineering. That's my addition. For the Day or other day 3 or 4 that Dr. Yosi mentioned, Bu Helena, I'm not wrong. It is part of the what Dr. Yossi called a below ground management, with using organic matters, uh, not taking the rice straw from the field, the decomposure, and then the intermittent irrigation that might be help to promote the good environment for the Collembola and Siromyidae population as a part of the prey for the predators, the general predator. As Dr. Yossi mentioned about whale settle work in Indonesia, that's that's the focus of giving early prey for the predator so they can survive. And when the pests, whether the PPH or the pests come, they will control it. So I think that's a thing. The problem is that, like Dr. Yossi said, it is not easy to persuade people, farmer or maybe decision maker, to believe that without spraying pesticide, we won't have any problem. It is a contra-intuitive. So that's why we have to create more creative thing. And we now join with us here is Dr. Johnny is how to, it's not not only just social engineering, how to learn together with farmer field school, learning from the fact, learning from the experience, because we cannot talk without doing this one. I think that's what I call this one. Research on the non-pest insect in a rice field is very limited. That's why if there is some student would like uh, to give a research and a part of the ecological engineering promotion, it might be better to right now to look at the zero-media population, the effect of organic matter, the relationship with the various predator, general predator from the dragonfly, spider, and something like that. And also the relationship among the refugia plants with other parasitoid. That's a lot of good basic messages that might be good to be a topic for the bachelor studies student and also maybe up to PhD student. I think that's all what I need. Hopefully the answer of the question perfectly. Thank you.
Thank you, Dr. Hermanu. Thank you for additional information about brown plant hopper, right? And I still have one question for Dr. Rafi in the chat box. This is from Afandi. I think you know Dr. Afandi, Dr. Rafi?
Yeah, he's a good friend of mine.
Yeah, this is, from Dr. Afandi. His question is, some technique to control pests already available, but it is not delivered to farmer exactly or accepted by farmer exactly. So his question is, what is the most prominent strategy to make those technology could be well accepted by farmer? Please, Dr. Rafi.
Yeah, thank you, my friend, Dr. Afandi. Yeah, I agree with his question. What we are doing is I'll give you one example. When I was working in potato leaf miner, which was a very serious problem in the Philippines, there was an outbreak, and I was asked by the minister to show how to control this problem. So, we had a lot of research. We already have very good research on leaf miners, not only in the Philippines, but everywhere. But farmers were still using a lot of chemicals. So, we use different strategies. So first of all, what we did is, aside from that, we developed science comic. It's a comic. So now we teach children in the school about leaf miners, the farmers' children in the rural areas. That we were teaching them how to manage leaf miners. So when they go home, they show their parents, oh, this is what we learned about leaf miners. This is what we learn about leaf miners. The same strategy, I thought of this as one of the strategy, because the same kind of strategy I used for controlling rice gall bleach in Africa. We have very good research, we have very good findings, but how to convince the farmer? So, like, the non-formal education techniques, like, comics, like, for example, dramas, like more of farmer field schools that are season long, not just 1 day training, 2 day training. That doesn't help. That doesn't. And of course, to also have small demonstration plots at the same time when you are doing different non-formal education techniques to promote, for the farmers to encourage. And if I'm a farmer, I also want to see whether it really works or not before I'm going to use it. So we have to show. It's a show and tell. Is you have to show and tell and demonstrate that it works. And many farmers now, so for example, in the Philippines, for the potato leaf miners, you hardly see farmers in the potato growing areas using chemicals to control a leaf miner, that is Mysa, which is also a serious problem in Indonesia, in Vietnam. So this is my suggestion. I think we have to use more of a non-formal techniques rather than, many of the entomologists, many of the crop protection people have to learn about more of farmer behavior and more of doing social, techniques to non-formal techniques to promote the research work. That's all.
Thank you, Dr. Rafi. Thank you very much for all two speakers for a nice presentation and nice discussion today. I think we have limited time. So before we close this event officially, I invite both speakers to deliver a closing statement. Maybe for first closing statement, I invite Dr. Hermanu, please. Unmute your speaker, Dr. Hermanu.
Thank you. Thank you very much. It is a pleasure and with a good experience talking with our colleagues on University Andalas and also meeting with Dr. Yoshi. I think for the real challenge in the future for the practicing agroecological engineering or ecological engineering in the rice cultivation is on the way we can persuade other person that the theory is right and can be done. From my experience, the best way to show that thing is not by talking or publishing, but by giving them the result in the field, uh, especially if it is practiced by the farmer. So farmer to farmer is more important to do to persuade other people to practice agroecological engineering. For the university, I think it might be good to have a partner uh, partner to work together and then to learn together, to develop science together, what we call it a participatory technology development, and also in the way we are communicate with public. In Indonesia, in most cases, the burden, the bottleneck is in a government, because the policy sometimes is counterproductive with the, the theory and the paradigm. I think it's not only in Indonesia, but also in other countries. And also in Indonesia, we are combating with the progressive advertising marketing strategy with the pesticide company that we would like to regulate that one, because we treat the pesticide and as what we call fast moving good, like a chicky or like other things. That's why we would like to give more regulation, and we ask for the pesticide company to cooperate with us to combat with ecological research and also physiological research on the pesticide use. I think that's all. Thank you very much. Thank you, Dr. Yossi. It's glad to meeting with you. Hopefully we can work together with Andalas University and also Indonesian scientists. Thank you.
Yeah, thank you, Dr. Hermanu. And then we invite Dr. Ravindra Joshi to give closing statement for us. Please, Dr. Rafi.
Thank you so much for inviting me to this very important webinar. I have really learned a lot from from the earlier speaker, Dr. Hermanu. His presentation was very good, and also his concluding statements. I think everything I wanted to say, Dr. Hermanu has said very well. So I really appreciate it. But well, few things that I want to say is that the policy, the most important is you can be a best researcher in the world, but if your government doesn't support the policy implications, because I have worked also in the policy matters in other countries, because I was the advisor to the minister in Solomon Islands, in Fiji. So I saw a lot of good research done by people, but it doesn't translate into policy. So the first thing I did was the policy change. So preparing a policy for the next 5 years. And so I included some of those things. One of the things why ecological engineering is very famous in China and in Vietnam is because of the policy. China has a policy. China has now a policy. Whichever farmer will do ecological engineering, they will get some subsidy. So now farmers are encouraged, because first of all, if you are a farmer, you think first is how do you save money? How do you reduce the cost of production? And whether what you are doing, is it effective or not? From the scientist point of view, we know that some of the techniques that we develop, whether ecological engineering or whatever techniques we develop or technology we develop, it has to be first of all effective, less laborious. The third thing is easy to do. And the fourth, it should not cost anything extra to the farmer. So from the technical side, we know that any technology we want to promote as a researcher or a scientist should have those things. Now coming for the policy side, we have to convince the policy makers to translate our findings to a policy that the farmer can be able to. So in China and also in Vietnam, they have provided incentive to farmers who are using ecological engineering principles. Now, like say, for example, in the Philippines now, the cabinet has approved the organic policy. So it is not in conflict. And also Dr. Hermanu mentioned about it, that the pressure from the chemical company is very high. So now we are also developing techniques on how we can work with the chemical companies to in not completely exclusion, but how to integrate in a way that we can still reduce the cost of production, because the biggest problem of the farmer is now the cost of inputs. So I think this seminar is very useful, and I think the universities should now direct some of their students and projects to put more emphasis on ecological engineering. And we, like, say for example, Dr. Harmanu and the other people that I know who have a lot of experience on ecological engineering, we set up a cooperation. We set up, some of us can be thesis supervisors for some of the students. We can share our experience. We can provide the resources, like mentoring program. We can mentor. It's not about money. It's about, like, say for example, I'm a mentor for the Merle William Fellowship Foundation, which is under the ACIAR in Australia. I am one of them as a mentor. So I am now mentoring a student from Cambodia and from Fiji. But I don't get paid, but I am able to move the research forward in the way it should go to help the farmers in other countries. So I think the university can, think of not just having this webinar. We can have a series of webinars where we can spend more time on how we can progress and how we can promote further the ecological engineering, and how we can also help collaborate with other researchers in Indonesia. SAFE network is a very big network in Indonesia. Every year we have an annual conference. Last year we could not have it in Jeju Islands, but we did a lot of webinars. So and now I hope that in the 2021 the situation may improve. We may be able to move. I think we should organize maybe some activity with SAFE Network, which is in Indonesia. But SAFE Network is not only about Indonesia, it's about so many countries. People from Pakistan, Bangladesh, Sri Lanka, they are all in the network, in Malaysia. So I think this is one of the areas. And the university, Andalas University, it is based in Andalas University. I think this is a good opportunity for us. I am the SAFE Network Coordinator for the Pacific Island. I don't get paid, but I like the work because I'm able to promote what the future research should be done. So thank you so much. And before I forget, if anybody is working on rice, because SAFE Network has recently asked me to write a chapter on ecological sustainable pest management.
Oh,
so I will have a separate chapter in the book on invasive species on rice. Anybody who is attending this, who is interested, they can be a co-author with me as long as they can contribute significantly to that chapter. Thank you so much.
Thank you very much, Dr. Rafi, for the nice closing statement. And I forgot, I already promised to Bapak Joni. Pak Joni, masih di sini kah? Bapak Joni, sudah keluar ya? Oke, mohon maaf tadi saya lupa kalau saya sudah berjanji untuk memberikan beliau waktu untuk membagi ilmunya. But finally, thank you very much for all participants. Thank you very much for the two speakers, the best speakers that I see before. And for Dr. Rafindra Joshi and Dr. Hermanu Triwidodo for valuable experiences and valuable knowledge. How we can collaborate in other events. And then we go back to Master of Ceremony, Dina Saptria. Thank you very much.
Okay. Sorry, Mr. Dr. Mai Sarawati, is my sound clear?
Yes, clear.
Okay. Thank you to moderate Mrs. Dr. Mai Sarawati. Thank you so much to the speaker for informative and interested presentation and participant for active participation. Stay with us. We would like to present second appreciation to speakers. So we kindly invite Mrs. Professor Dr. Nurbailis to closing and appreciation. Mrs. Professor Dr. Nurbailis, please come.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
For the first, let us praise and thanks to Allah Subhanahu wa Ta'ala for giving us the opportunity to participate in this event. Greeting also we send to our great Prophet Muhammad Sallallahu Alaihi Wasallam, who had brought us to the bright life like now. The Honorable, our speaker, Dr. Ravindra Yosi and Dr. Hermanu Triwidodo. The Dean and the Vice of Dean, the Agriculture Faculty, Andalas University, the Head of the Plant Protection Study Program, Agriculture Faculty, Andalas University, and all the participants is visiting lecturer who has participated in this event. We say Alhamdulillahirabbil alamin because we have finished listening what was spoken by our speaker who are competent in their knowledge. The exposure of this topic has added to our insight and knowledge in our study of integrated pest management of rice. This event was attended by more than 100 participants from whole Indonesia, maybe from Sabang to Merauke. For that, we want to express our special thanks to the speaker who has provided enlightenment and shared knowledge to all of us. Hopefully, what you have done is become worship inside Allah Subhanahu wa Ta'ala. We also express the special thanks to all the participants who has passion to follow from the beginning to the end of this event. On this occasion, on behalf of the organizer, we would like to apologize if there are things that are not pleasing in the implementation of this event. That's all. We close this event by reading Alhamdulillahirabbil alamin. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Bu Nurbailis, there are two certificates for the two speakers.
Okay.
I will share to you. Wait for a while.
Yeah, this certificate for Dr. Ravindra Yosi. Please, you decide.
Thank you. Thank you so much.
Yeah.
Thank you. Thank you.
Okay, yeah, thank you. And next, Miss.
This is for Dr. Hermanu.
Yeah, this is a certificate for Dr. Hermanu Triwidodo.
Terima kasih Bu Nurbailis.
Ya.
Sehat selalu, penuh semangat dan gembira.
Amin. Terima kasih kembali Pak Hermanu. Ya, saya kembalikan.
Dina?
Okay. Thank you so much, Mrs. Professor Dr. Nurbalis, for closing statement and appreciation to our speakers. Finally, we come to the end part of this seminar. The agenda is photo session. For this session, I would invite Mr. Chico to take the photo. Please take the photo of participants slide by slide. For all participants, please turn on your camera and give the best smiling. I will be wait for you.
Please turn on your camera.
Can stop share screen?
Okay, I'm so sorry. Okay.
Smile.
First slide. And then finish, Chico? Chico, are you there? Or Pak Asmiandi, could you please help us to take a photo for all participants?
Finish. We already take the picture.
You already?
Yes.
Okay.
Thank you.
Okay.
Okay. Thank you very much for taking a photo. So, dear audiences, ladies and gentlemen, we come down to the end of the seminar. We would like to extend once again our department appreciation to you all for your support in participating. Hopefully, the seminar will be finished now for everybody. Amin. I am Dina Septria. As the master of ceremony, beg your pardon mistaken we have met. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Congratulations, Miss and all.
Terima kasih Pak Hermano. Thank you Pak Raffi.
Thank you.
Pak Manu sudah bersedia berbagi ke Universitas Andalas, Pak. Thank you, Dr. Ravindra Joshi.
Thank you. Thank you.
Even so, you are sick, but you are being here.
Thank you.
Hopefully, you get well soon, Dr.
Thank you. Thank you.
We close now.
Ya, makasih Bu Miss.
Ya.